Hello everyone, in this video I'll be explaining quicksort. There are a few things that we need to know about quicksort. First of all, the time complexity of quicksort is big O of n square. Quicksort algorithm works on divide and conquer technique, same as merge sort algorithm. Overall, the main goal of quicksort is we first assign a pivot element. The pivot element can be the first element or the last element or any random element from between. What we do is we assign a pivot element and after that swap all the smaller elements to the left of the pivot and all the larger elements to the right of the pivot. Now I will explain quicksort algorithm with the help of an example. So we have an array over here. Let's call it R. All the elements are jumbled and these are the indices of the array, and the size of the array is 7 because the index starts from 0. We'll consider our initial low as 0 and high as 6. Okay, I will tell you how quicksort works overall now. So here we have this array. What we do is we assign a pivot element to this array. So in this algorithm we start over here. Okay, if low is less than high, we call this partition function, which will return us an index, and that index will be the pivot element. Okay, so we have the array and we assign a pivot element, and this partition algorithm will send all the smaller elements to the left of the pivot and it will swap all the larger elements to the right of the pivot. Now we have two arrays over here with all smaller elements than the pivot over here and all the larger elements than the pivot over here. Again we will assign a pivot element and all the smaller elements to this pivot will come here, and this will be an array, and all the larger elements will come to the right side. Same for this. Smaller will come here and the larger will come here. Again for these two we will assign a pivot. We keep continuing this process and at one point of time the entire array will be sorted. So this is how quicksort works overall. Divide and conquer algorithm. And for this particular example, we will be considering initial pivot to be the last element. Okay, now let's do a dry run of this quicksort algorithm. We will consider the last element as pivot. Now what we do is we call a partition function. Okay, in partition function what we do is we will have an initial index I will be low minus 1. Low is 0, low minus 1 is minus 1. Okay, then we'll have a for loop which goes from low to high minus 1, that is here, from 0 to high minus 1. Now this is the main condition that we have to check, which is array of j, whether it is less than the pivot element, and we have j index for the loop. Okay, so now initially j is low, so j is 0. Now we check if array of 0 less than pivot. Okay, so what is array of 0? 70. Is it less than pivot element 40? No, it's not. So we don't do anything. We again go through the loop. So I will become 1 this time. Array of 1, is it less than the pivot? Array of 1 is 80. Is 80 less than 40? No. So we don't do anything. We again go through the loop. Now j increments to 2. Array of 2 is less than pivot. Array of 2 is 10. Is it less than 40? Yes. So now what we do is we do I plus plus. So now I becomes 0 and you swap I and jth index. Now j is currently 2 and I is currently 0. So we have to swap the elements in these two indices. The array will look like this. 10 will come here and 70 will go to the second index. Then we'll have 80. The remaining elements, we'll just write them as they are. And this is our pivot, which is 40. Okay. Now we still have to continue with the j loop till high minus 1. So j will now be 3. And again we check, is array of 3 less than pivot. So now array of 3 is 20. Is 20 less than 40? Yes, it is. So we will increment I. Now I will become 1. So I is here and j is here, 3. So now we have to swap these two. 20 comes here, 80 comes over here, and 10, 70 remaining we just copy them. Okay, j becomes 4. Array of 4 is less than pivot. Array of 4 is 90. Is 90 less than 40? No. So we don't do anything. We go back to the for loop. Now j is 5. Is array of 5 less than pivot? Array of 5 is 50. Is it less than 40? No. So we don't do anything. So now we have come to the last element, which is high minus 1, which is 5. So we exit the for loop and we come over here. Now what we do is we swap I plus 1 and array of high, that is pivot. We swap it with the I plus 1. Currently what is our I? I is 1. So we swap I plus 1 is what? I is 1 plus 1, so it becomes 2. I plus 1 is 2, so we swap 2 with array of high, which is this. Now we swap these two. This is the array that we get after swapping the pivot with the I plus 1th element. So now if you can observe, this was our pivot. All the elements to the left of the pivot are smaller and all the elements to the right of the pivot are greater than the pivot. Okay, so now what we do is we apply quicksort, the same steps that we did for the entire array. Now we will do it for this half and separately for this half again. So I'll show you quicksort on this part of the array. Now we have our new divided array on which we will call quicksort. I will just show you where it is in the code. So here we have our previous code. So we call quicksort on array of low to pivot minus 1. So this is the left subarray. And here we call from array pivot plus 1 to high, which is the right subarray. So now our new low is 3 and our new high is 6. And we will run the j loop from 3 to 5. So here we have our index j. And what do we check? If array of j is less than our pivot, and we'll have our I index. I will be what? Initially I will be low minus 1. Low is 3, so initially I will be equal to 2. I'll write that here. And j is initially 3. Okay, so now is array of j, that is 80, array of 3, which is 80 less than our pivot. We will consider the last element as pivot. So is 80 less than 70? No. So we don't do anything. We go through the for loop. Then j will become 4. So there's 90 at 4th index. So 90 less than 70? No. So then I will still be 2 itself. Then we increment j becomes 5. 50 is at 5. Is it less than 70? Yes, it's less than 70. So what we do is increment I will become 3, and we swap r of I and r of j. So I is 3 and j is 5. So we swap 3 and 5. 50 here, 80 here, swapped, 90 and 70. Now we know that j has reached high minus 1. So that's the end of the for loop. So what do we do after end of for loop? We swap array of I plus 1 with array of high, which is the pivot. So I plus 1 is 3 plus 1, which is 4, with the pivot element array of high. So 6 is high, so we swap these two. Now we get the elements. We swap these two, so 70 comes here and 90 comes here. 50 and 80 comes here. Our pivot was what? 70. Again we observe that all the small elements came to left and all the bigger elements came to the right. Now also if you observe, this array is sorted in itself. This array is also sorted, and this was initially itself sorted. It had come to the right position where it belongs. So now let's put everything together. One array. So 10 and 20, they were sorted, the left part. Then our initial pivot was 40. Now the array that we got of the right side is 50, 70, 80 and 90. Now if you observe, all the elements are sorted. So we have successfully sorted our array using quicksort. So this is how the overall working of quicksort is. If you learned something new from this video, please give this video a like, and also if you have any comments or suggestions, you can put it down in the comments below, and please subscribe to the channel, and that will make me really happy. Thank you.